actually start, before I ask you my questions, there was a great question that came up on the chat from Mr. Brownstone, and he was wondering, are you writing a book on this subject by any chance?
Well, at present, I don't really have any interest in writing a book, simply for the fact that I'm too busy with a few of my clients. But I think maybe in the future, a series of blog posts on how to write a very effective security skeleton, or maybe something in Codeplex where we can get the community involved. I think that's something I'd like to do, because when I did the Tech Day sessions on the security skeleton, I kind of identified a niche that was missing in the industry, and it's this notion of having a skeleton to protect your ASP.NET website. We have frameworks. Let me give you an example: Backtrack 5 and Metasploit. You want to find a payload, a vulnerability on a website, it's easy. You download those two tools and you can go ahead and even if you're just a junior, you can pen test your ASP.NET website. But defending your ASP.NET website, you're going to have to assemble bits and become familiar with them. So why not have a common repository and have that linked to your documentation? So I found that niche, and I think that maybe later on, if we can do a few blog posts on your MSDN Canada blog posts, well, perhaps we can get going in that direction.
Thanks for the little plug there. That was great. But actually, on the same notion of open source and stuff like that, Mr. James had a question for you. Other than the fact that he was saying, Joel, this is great stuff, and I keep saying Joel, I'm sorry, Joël. He says, it seems that a lot of this could be common to many projects. Do you have an open source project incorporating this via NuGet or similar? So I think you kind of answered that question, but maybe if you wanted to add anything on top of that.
Sure, I think that right now I don't have anything concrete, but there's definitely, I'm going to do something on Codeplex, where I'm going to start assembling the pieces. I'd like to do a blog post at the same time. So this way it's sort of like a teach as you go. So I find sometimes even myself, I go on Codeplex, I download some code, I'll put it on a site, but I'm not really happy with the documentation. And I find sometimes people think that other people will go on Codeplex, dump the code, and then try to profit from some consulting practices. I don't want to go that route. I'd rather do small steps, maybe a few blog posts a month, and let the community augment as well. So if Mr. I think it's Brownstone or Brown?
Yeah, Mr. Brownstone. Or Mr. James was asking.
James, okay, so if Mr. James is asking, he could come and augment, I'll augment, and we could work together and then build this ASP.NET security skeleton. If we take a look at the ASP.NET login, just as an example, has it really changed that much in 4 years? I've got about 40 things that I'd like to add to the ASP.NET login control, and perhaps we could add that in the Codeplex and move along, and maybe one day it'll be integrated in the product itself.
So let me ask you something. You started the talk by sort of focusing on documentation. And the part that, it kind of was an eye-opener for me was, that it actually starts all the way back then. Most developers would think, oh, it's just, standard coding practices that I have to make my applications secure. But your take on it was actually not so much even, obviously the code is important, but you were saying about the documentation. Why is it that you think that most actually, sort of don't have that in their day-to-day practices?
Well, for me, herein lies an intrinsic problem with some of our business processes or the SDLCs we use, is that the penetration testers or the security officers or the threat risk agents, the people that do the analysis, always come in at the end of the project. Reason being, it's quite expensive to do a pen test on your website, and this goes along by due to the fact that if you want to be a pen tester, it's quite difficult, takes quite a bit of a long time, there's a lot of risk involved. If you take a software architecture document and you model out the security vulnerabilities from the start, you'll be able to educate your developers right from the start, and as they're coding, you're going to mitigate against, let's say, anti-cross-site scripting or cross-site request forgery. You do that from the start, and you do it on multiple levels. Don't just rely on one thing. What happens is at the end of the project, you're not scrambling or worried about your release. You've got other things to worry about 2 weeks before the release, fixing the last few bugs that your clients want. It's not time to start worrying about the security or doing the TRE at that time. Evidently, you have to go live, and when you go live, you have to do the TRE on a production system. But if you do it correctly on a QAT system, it should be reciprocal to what you have, and then you can launch and go live and have no worries, essentially.
So I know when I'm talking to developers, one of the questions that I get often when it comes to security is how do you actually make the business case to clients, especially if you're building an internal enterprise application or corporate application. How do you make the business case for effectively building in code that doesn't have a business function, right? I find that the first response is always just get rid of it. We'll take care of it eventually, and then of course we all know that never actually happens.
I think there's a few different ways of doing so. One of them, if I have to do a push, if I have to try to convince someone, I usually go on Twitter and just show them the anti-sec feed and show them how many things are compromised. And if you take a look at some of the big agencies in the US, we won't name any of them, big security agencies, they've all been hacked last year. We had the emergence of new terms, the hacktivist, the privacy by design last year. So we see there's nothing is really secure. So sometimes you got to tell the customer that whatever you have in your database, if you expose that to the web, you have to be almost ready to share that with others, because there's no such thing as a secure website. It's very nice. Everybody likes to say that they're secure. They have these nice little things on their website saying they're hacker-proof and whatnot. This is not exactly the case. So you have to be very realistic with the client, explaining to them that, well, let's put these mitigations into place. Let's get your clients, because they might be your client, but they have clients themselves. Get those clients to have some confidence in you, and then that'll help you in your business practices. So if I secure your website, that helps you with your everyday business processes. That's going to help you and aid you quite a bit, but there's not really such a thing as a secure website. That's my true opinion.
Now, before I go to the questions in the chat, which you'll see me smiling, just because the conversation is absolutely great. I'll preface the question from Tester by asking you this first. Do security principles, or do the things that you were talking about in the documentation and in the preparation that you need to do those go away just because you're building an application that's purely for internal use?
I don't think so. Let's take, for example, a cross-site request forgery. The fact that you're persisting a cookie that somebody can go across, and then let's say that you have an application internal at the government. I'll give you an easy one for travel and hospitality, where you can manipulate funds for the travel and hospitality of directors. That's an internal product. Well, you don't want somebody who's an executive assistant clicking on something where a CRSF token gets sent across, and then it manipulates that money, and then maybe take some funds out. Sometimes it's not necessarily stealing money from someone, but if you take somebody who's a CIO, perhaps at the government level, and you see that the data has been manipulated, well, then that's going to spark something, an internal investigation, and that's where the cost lies. So if you have an internal investigation on why there's all these TNAs that are all over the place, you're going to have to probably spark an internal investigation. It's going to cost you quite a bit of money. So for an internal app, you probably won't have to do as much, but you still have to put in the basics. That's my take on it. Like protecting against a distributed denial of service attack on the internal site is ridiculous, but definitely cross-site scripting, SQL injection, and all of the basics should be handled.
So the reason why I asked that was actually because Tester on the chat was saying, do you trust all your coworkers, right? So, Tester was talking about that's actually one reason to build security into your in-house applications, because you can't necessarily trust every single one of your coworkers. And then, of course, Mr. James adds on that it's not just the coworkers, but it's actually even the deployment team, the support teams, and everybody else that's in the process.
Yeah, I have to agree with that. One thing that I've seen recently is, how we say don't store any passwords in the web config and we encrypt that. I've seen someone actually go as far as there's no passwords written down at any time. There's only one person who actually knows the password, the database person, puts it in, does a deploy, and then that's it, it's forgotten. That's the only person. So the least people that have these secrets, the better it is, and I have to agree with them. Sometimes it could be a disgruntled employee, sometimes it could be a client, sometimes it could be somebody who handles the deployment.
Not that that would ever happen, of course.
It all depends. Party? No.
So in talking about all of this, and security obviously vastly important, you started off the conversation by talking about securing web applications. What if we took that one step broader and say, okay, well, how do we secure and then subsequently test for any .NET application? So, if it's a worker process or maybe a phone application or a cloud application, I'm assuming these principles all still maintain the same, maybe just their implementation is slightly different.
That's correct. So usually if you have a vulnerability, it's common across all vectors. So if you're utilizing a phone and I decide to put an SQL injection attack in there, if you have an SQL backend and you're not mitigating against it, it's probably going to go through a web service, which is not a great example. Like a web service, you have to cleanse what comes in because that's going to go to a data store at a certain point. So whatever affects your .NET Forms application, whatever affects your web service, whatever affects your Windows Phone, they're approximately the same. So you have to mitigate at all levels.
Cool. And then from a tooling perspective, I know you went through some of the tools in your talk, but is there stuff that developers can use that's actually built right into Visual Studio that would actually be able to help them, kind of get started right away, and then, add on all the additional tools that you were showing?
Well, some of the things that I like from Microsoft, right now they have a web protection library that has the Microsoft anti-cross-site scripting integrated into it. I like that one because it comes to augment. So if you take a look at ASP.NET, the request validators, personally, since I know a few things, I can bypass them. I know about 7 techniques to bypass those request validators. So what I like to do is I take the Microsoft anti-XSS, I add it, and it comes to augment. It also whitelists, and it does quite a few nice things. You can use things like get safe HTML fragment, and I'll go and clean the code. So now what happens is you have 2 levels of security. You have the request validators, you have the anti-XSS. I like adding an HTTP module that verifies cookies, form values, anything that's posted, and that's sanitized at that level. So it has to go through all 3 levels. So this way, whatever is getting entered on your website is almost not foolproof, but it's quite a bit safe. To add to that, I think Microsoft added a CAS, code access security, inside the Visual Studio, and there's also a scanner now that you can scan, and it tells you what's wrong with the code or attempts to tell you a few things. I forget the name, but I've run it before, and I think that was in beta when I first got Visual Studio 2010. But that is a great tool. To augment the question, if you're interested in a tool, see here, Metasploit. That's the tool here that you want if you want to test your web applications. Metasploit, and I would say Backtrack 5, it's a Linux tool. Those 2 things will incorporate everything that you need. They're all integrated.
Perfect. I actually see that we have Steve that's here with us as well. I thought we weren't going to have him, but let's see if we can actually get him connected in here, because that would obviously be great to have his opinions as well. Here we go. Look at that. It's spoken like a true security expert. Let me get him over to you guys. Look at his avatar there, right? You can't get any better security than not having your own picture. Hey Steve, how's it going?
Hey Jonathan, I'm good. How are you?
Good, good. Thanks for joining us. And I was actually I was worried, in terms of just to give you guys a little bit of a funny story. When I was preparing for the show, and all of the introductions, I said to Steve, I'm like, Steve, do you have a picture that I can put in the show? And he's like, dude, I'm a security guy. I don't do pictures, just voice. I may or may not exist. So
I only exist in the ether.
There you go. And for those of you guys who actually haven't met Steve Syfuhs, he's actually a developer security MVP as well, and certainly talks about security pretty much night and day. And Steve, you mentioned something very interesting in the chat there about not all attacks come from a hacker. Mother Nature is the biggest attacker. What do you mean by that?
Okay, well, it's actually kind of a funny story. So about a month ago, just right after Christmas, I moved to BC from Toronto. So I'm in a small town called Chilliwack in BC. And for the last month or so, we've been ramping up to release a new product. Well, actually, a couple new products and a new customer portal. We've decided to migrate everything to the cloud because that's where everything's going. So last week
he said the magic word, cloud.
The cloud.
I'm
Yes,
going to have to ask you about that a little bit later.
we can talk about that later. So last week we decided to deploy, and there has been some rampant power outages around the office, and it's funny because it wasn't the whole city; it was just our little block. We're in a little residential area for the most part. There are a couple offices around, and the power just went out, and my boss and I were driving down the road. We just grabbed some dinner because it was a late night, and we're driving, and all of a sudden the power goes out right in front of us, and he's swearing and I'm swearing. We get back to the office, power is out, and we say, okay, that's fine. So we go off and we're doing something else. Power comes back on, and he gets a flat tire as we're still driving around. So all these different things are lining up, and we haven't actually touched the deployment yet. And at one point, our internet crapped out, so
nice.
It's just gone. It's down to, we're uploading at 5K a second, and it's a relatively large package. It's about 20 megs that we need to upload, and it takes time on a 5K up. So at one point on Friday, we were up all night Thursday making sure everything was working, and then Friday morning I get into the office, power goes out. Okay, great, we're in the cloud, we don't really care about it, and then we realized that we had a minor bug in our deployment. Things didn't work, and the power was out. We knew exactly what the bug was. We were ready to deploy to fix it, but we couldn't do anything because power was out, internet was down. There was nothing we can do, so we decided, you know what, we're going to go to our disaster recovery site, which was across town. It was the only place in town, by sheer luck. It was the only place in town that actually had power. There was a fire at the power substation. Power was down all day. There were a couple angry customers, but after everything was back online, everybody was happy. We explained what happened, and they're just like, really, the substation actually caught fire? It's like, well, yeah.
And so what
some of these things you can plan for. Some of these
perspective, though.
Well, from a security perspective, there were no vulnerabilities. The problem was that we were down.
Got it.
So that was the problem. There was no. The interesting thing was there really was no way to resolve the problem without having power. So what did we do? We had a backup site. So we drove to the backup site. We stacked up all our computers. We turned them on, and it took it took an hour to do the move. It took 5 minutes to write the patch. It took 20 minutes to deploy, and we were back online.
Wow. Hey, Steve.
So the moral of that story is Mother Nature is a very big attacker. It happens more often than you think.
Now, I asked Joël this question before, and also with you, you did a session on cloud security at Tech Days. The question that I had for Joël was actually, how do, if they do, security principles change when you're changing the type of platform that you're working on? So very quickly, from a cloud perspective, some of the standard, the standard security principles, do those change just because you're going to the cloud? Do you need to be doing more or less because you're in the cloud?
About 10 years ago, someone coined the terms the 10 immutable laws of security. As a developer, we know that immutable means essentially that it cannot change. Funny enough that they're on version 2 of that. But security really doesn't change at a principle level. When we say, when we look at different types of attacks, conceptually, they never change. It's just a question of how are they implemented, how do we protect against them. The cloud is really no different. By deploying to the cloud, you get some benefits. For instance, you get automatic patching, so the attack vector of a 0 day or a flaw in a design that just got patched. We don't really have to worry about things like that just because we're not managing. Well, we don't. It's not that we don't worry about it. It's that there's nothing we can do about it.
Right.
So we tend to push it off to the side and hope the people that we're giving money to are actually doing their job.
Of course they are.
We have trust in them. And at the same time, there are a couple new security problems we have to worry about. For instance, everything's now running in virtual machines, so there are new attack vectors that crop up because everything is sort of coexisting on the same machines. You could potentially have an attacker who's sitting on the same physical hardware as you in a different virtual machine. So how do you protect against them breaching the underlying hardware and going across the hypervisor into your system?
Makes sense. Makes sense. Well, gentlemen, we're actually right at the end of the show. Thank you so much for joining us. Again, guys and gals, I should say, that are watching, if you have any questions for Joël or you have any questions for Steve in terms of anything security related, both from a web perspective and also from a cloud perspective, join us on the LinkedIn group, and we'll answer those questions there. Thanks so much for joining us, gentlemen, and we'll be in touch shortly.
Thank you.
Thank you, John.